All the time. Okay, we can probably get through the lymphatic system in the next 15 minutes. Because there's really, this isn't a major system that has tons of parts. There are some major vessels that I want you to know, and some organs. Lymph is simply the interstitial fluid that flows out of the capillaries. At the capillaries, the pressure is still positive. There's pressure going out of the capillary, driving the blood plasma out of the capillary beds. So all that fluid that flows out doesn't flow back in. The lymphatic system is there to catch it and return it to the right atrium. Then that lymph mixes with the blood, rehydrates it, and goes to the lungs. Right atrium, right ventricle, pulmonary artery to the lungs. There are lymphocytes and macrophages. These are your agranular and granular leukocytes swimming around in the lymphatic system. Now the lymphatic system makes the lymphocytes. The macrophages are made only in the blood bank. All of this is connective tissue. They can be fixed or wandering macrophages. You remember the connective tissue chapter at the very beginning of the semester? We talked about fixed and wandering macrophages. This is where they come back. And we put them into context. You have lymphatic vessels, which are typically named after the veins that they travel with. Primary lymphatic organs produce stem cells that differentiate into the different types of lymphocytes. The primary organs are the bone marrow or the thymus, which is right here behind the mediastinum. We have a pretty small one. When you took apart the minks or the cats the other day, the minks have this huge thymus. Humans, it's kind of degraded down to a little star-shaped thing behind the mediastinum. Secondary organs hold on to the lymphocytes. Those are your lymph nodes or your tonsils, and you can have those removed. All they're doing is sitting as a holding area for the daughters to mature. They're already differentiated into B, T, or NK cells, and then they just go there and sit and wait for an infection to occur or cancer to occur. So our blood pressure gets down to around 35 millimeters of mercury, so pretty low, but still not as low as the pulmonary pressure. This is out at our capillary beds. And about 3 to 4 liters of blood plasma every day is lost at the capillary beds, out into the interstitial fluid. Lymphatic vessels return this to the right atrium. They also provide an alternate route of transport for hormones, nutrients, and waste. So hormones that are released can be picked up by the lymphatic system and brought back, dumped into the right atrium, where they're going to go into circulation. Lacteals are these little finger-like projections that are highly expressed, or a lot of them are found around the intestines. We'll talk about the significance of that in just a second. But the capillaries have a non-continuous basal lamina. So they're kind of between the fenestrated circulatory capillaries and sinuses. So they're really holy, which allows them to pick up all kinds of lymphocytes, all kinds of blood plasma or interstitial fluid, cells, formed elements, bacteria, viruses, foreign particles. Everything comes in through these lymphatic capillary beds They're not multi-layered. They don't have that tunica adventitia, that thick connected tissue like the blood vessels do. They're valved to produce one-way flow, and then they also do have some smooth muscle. And this smooth muscle contracts in a rhythmic contraction to keep lymph always flowing up toward the heart. These valves, which I'm sure you've seen before in veins, are shaped kind of like this, and the flow is always going in this direction. So that once it flows through, it can't flow back down. So it's a one-way valve. They're also just like the veins. Located between skeletal muscles that cause them, and the skeletal muscles are moving the blood up toward the heart. I'm trying to find a good picture of that. I guess this is the best picture I'll find. So in my gastrocnemius, I have this large vein flowing. And as I walk, what happens is the two bodies, or the two fascicles of my gastrocnemius, are always just squeezing that vein. Because there's valves in there, they can't squeeze it back down. So that pressure, when I flex my gastrocnemius, pushes blood up toward the heart. This is happening in the fascicles of my gastrocnemius, my semimembranous, semitendinous, biceps femoris, all of my quads, the vastus muscles, my gluteus muscles, my abdominals. All of these muscles are just squeezing blood up toward the heart, and it can't come back down. Another thing that's pulling blood in my veins and in my lymphatic vessels is when I breathe in, my diaphragm contracts and it creates a vacuum. One thing that does is it pulls air into my mouth, but it also pulls blood up from below, up from my inferior vena cava, up into my thorax. Then once it's in the thorax, it can't go back down, so it just goes back into the heart, based really on just expansion of the right ventricle. So you have all of this pressure and then suction pulling your venous circulation, because there's really no pressure there at all. But back to lymphatic system. The lymphatic vessels travel with the veins of the same name. You're going to have a cephalic, a bacillic, a jugular, subclavian, axillary. All of those veins share their names with lymphatic vessels. So you have a major superficial system, and then a deep system that drains skeletal muscles and organs. So your visceral organs go through the deep system. Superficial are the mucosal membranes associated with all of these organs, and the serous membranes associated with the deeper organs. So basically the point is you do have a deep and a superficial system, just like you do with veins. Major trunks are the intestinal, bronchomediastinal, subclavian, jugular, and all of these trunks dump into the thoracic and right lymphatic duct, or lymphatic trunk. This guy right here, cisterna chyli, is it's an important structure located right here, and it's really just the origin of the thoracic duct. It's where all of the lymph from your legs come in, but it can get occluded which causes many cases of elephantitis or elephantiasis, where people's legs, and then the most popular pictures are when people's genitals get massive, and massive, like worthy of viral pictures on the internet, massive. Because lymph can't drain. And so what happens is all this fluid gets built up in people's legs or other parts of their body. The thoracic duct, you can see right here, drains almost the entire body. The legs, the left arm, the left head, the entire abdomen. The right lymphatic duct just drains the right arm, the right chest, and the right head. So it's very asymmetric. The different cells we've talked about before, but T cells are made in the bone marrow, then migrate to the thymus. B cells are made in the bone marrow and then go right out into circulation. They don't have to go to the thymus to mature. NK cells are made in the bone marrow and then released straight into circulation, held in the spleen, held in the thymus, and held in the lymph nodes. T cells are primarily xenocytotoxic. Xeno means foreign, so they are toxic to foreign cells. They release cytokines, which are chemicals that attract everything else. They attract those macrophages, those granular leukocytes. And they keep a memory so that when, say you get the Black Plague, the bacteria, 5 years later, you're unlucky and you get the Black Plague again, you can fight it off because these T cells remember. B cells make antibodies. That's this very specialized immune function where they make antibodies to attract macrophages that are then going to engulf the bacteria, the virus, whatever it is. And finally, natural killer cells are primarily responsible for killing abnormal cells. So these natural killer cells are what we are increasing the function of when we are targeting cancer with immune treatment. So what we're trying to do is enhance the activity of these NK cells. They also do things that T and B cells do. This is the last slide we'll do. Last thing we'll talk about. MALT, mucosa-associated lymphoid tissue. This is where your lacteals are. These innervate the gut, all of the organs of the gut, the stomach, the intestines, the large intestine, the colon. And there are all these little fingers that come off into the mucosa of these organs. One thing they're doing, you eat a lot of bacteria all day. They're taking in that bacteria and killing it. But they are also absorbing lipids. What this does is it allows lipids to shortcut the system and go straight into the lymphatic system, which is going to go straight to the blood. So lipids can bypass the hepatic portal system through the lacteals, which is one reason that pharmacists try to make drugs extremely lipophilic so that they can bypass the hepatic portal system. Now, this doesn't pick up 100% of the tissue of the lipophilic substance, but it can pick up a good portion of it. So a lot of drugs are meant to be lipophilic so that they'll go straight to the lacteals. And also, if they're lipophilic, they can bypass the blood-brain barrier. Remember that thing. So then the tonsils and the appendix, all these lymphocytes are going to sit and wait to be called by cytokines that the T cells or NK cells are releasing. Okay, wow, we're late. Go, leave. Bye. So,